Welcome to this course on computational complexity theory. So this is a basic course in complexity. The prerequisite is none, but if you have done theory of computation, then many of the concepts in the initial chapters will be easier for you. In this era of computing, a very relevant question is what problems can a computer solve, right? And what are the problems that a computer cannot solve? So to answer this question, or even to study this question, you require to formalize two things. You have to give a mathematical formalization of what is an algorithm, what is a computer, and what is a problem, right? So you have to mathematically formalize both the things. What is your computing model, and what is the problem that is being solved, which may not be immediately clear in the beginning. Okay, the formalization is not immediate. In fact, the first good and universal formalization was given by Turing, by which we call Turing machines. In this course, we will do that. We will start with that. We will formalize both computing models and problems. And once we have done the formalization, then the main chunk of this course is to classify problems into complexity classes. Okay, so this classification into classes, which we'll call complexity class, this will be done on the basis of hardness or easiness of the problem. Okay, so there will be complexity classes which collect problems that are easy, and there will be complexity classes which collect problems that are hard. Okay, so the harder complexity classes are above. You can think them as above, and the easier complexity classes will be below. So they will be contained in the bigger complexity classes. This hardness, easiness will be in terms of time, space, or maybe some other resource. Okay, for example, non-determinism, randomization, and so on. So some of the famous complexity classes or basic complexity classes are P, which is deterministic polynomial time. Then there is NP, which is non-deterministic polynomial time. And the third is Exp, which is exponential time. And then you can also, in terms of, if you think in terms of space, then there is P space, which is polynomial space. Okay, and then you can ask immediately this question, whether these classes are equal or different, whether one is contained in the other. Right, so we'll study these questions and we'll answer them. And the problems that we'll study, they will have practical significance. So we actually are modeling problems which actually appear in practice. Okay, so there is both practice and theory. So I hope you'll enjoy the course.